Here we go, we have a question XOR linked list. So this particular function is different, the code is different for the C++ and the Java. So I solved the Java code already, and it is pretty clear that only this description is important for this, because here the XOR function is not given in the driver code, but in the C++ XOR function is given in the comments and here also. So we have to solve using the efficient manner in the C++ code. So let's read the description first. A ordinary doubly linked list requires space for two address field. We are familiar with the doubly linked list concept. So it stores the previous and next pointer. A memory efficient version of doubly linked list can be created using only one space for the address field with every node. This memory efficient doubly linked list is called XOR linked list or memory efficient, as the list build uses XOR operation to save space. So you have given two functions, insert and getList. Insert function pushes the element at the beginning, and getList function returns the linked list as a list. The note here is a utility function XOR. So this is the XOR function that is only given in the C++ language, not in the Java language. Takes two node pointer to get the bitwise XOR of two node pointers. So you have to use this function to get the XOR of the two pointers. So we don't have to go in depth of this predefined XOR function. The driver code prints the return list twice, once forward and once backward. So this is just for the understanding purpose what the driver code does. So next we have this list. So this list, the next and previous pointers is just for visualization. We have npx pointer. Npx means next, previous, XOR. So we have to use only a single pointer to point to previous node and the next node as well. So that's about the description. Let's try to build the approach. So initially we have head as empty. So head is null. Next, we have to insert a value. First, we will create a new node. So let me create a new node, a value 1, and its npx is initially null. Npx is initially null. So head is there. Suppose head is there. Head value is null. So for every this is called new head, we have to insert in the beginning. So its next and its pointer, its head previous pointer we have to initialize. How do we initialize? We have only a single pointer npx. So first this npx will behave like next. So new head dot next will point to the head node. Although the name is npx, but it will work as the next pointer. We just need to do new head dot npx is equal to head. So after doing this, we have a pointer, but we also need the previous pointer. We have to do like this. So initially the head is empty, so we don't have to do anything. We just return the new head, and this is our new head. This is our head. Next, we have a new value and we want to insert at the beginning. So let's first create a node. The node value is 2, let's suppose, and its npx will point to head. This is new head, and we have to write this code. New head dot npx will be equal to new head dot npx, or in the C++ we have to use the arrow symbol. Dot npx will point to head, and we also need to initialize its previous pointer. Its npx value is null and its npx is initially head. We have to change its npx. Its npx is initially pointing to next. We can say that, but we want next and previous both pointer in a single node pointer. So we have to initialize the npx to next and previous at the same time. How do we do that? We have XOR function for that. So we just need to do npx. We are familiar that npx stores the next pointer only. Its previous is null. Its previous is null. But now we have to initialize the previous itself also. So npx, this is head npx. So head npx, we have to do the XOR to the head npx itself, means this is the next initially, and now its previous pointer is also getting added. So this is the previous pointer. What is the previous pointer? Previous pointer is the new head. So this is the previous pointer. So that's how we have to add the next pointer and the previous pointer. So after adding this pointer, it will point to this value. So this is just for visualization. This next, this previous and this next. This is just for visualization. So let me save this. So now we have to return the head node. This is the new head. So this is not the head, this is the head now. Next, we have to add a new value, a new node at the beginning. Let's suppose the value is 3. So we have to add 3. This is the new head. So first we have to do this. New head dot npx means its npx pointer will work as the next pointer. So first we have to connect this pointer. Next we have to connect this pointer. Head npx. Head npx, its npx only stores this. Only stores the next pointer. Only stores the next pointer. But we have to also store the previous pointer. How do we store that? We will do the XOR between head npx. Head npx is the next, and the new head. New head is the previous. So we just need to do this. We just need to do the XOR operation, which is predefined in the driver code. So after connecting this, we just need to return the new head, which is our head now. So that's about the insertion. Let's talk about the traversal. Current initially points to this value. We need 2 or 3 pointers. Previous is null, and we also need a next pointer. It is also null, and we want to store in a list. We need a list. Current is the head value. First we store the value. Next, we need to check Before that, let me tell you, its npx only stores the next value, its previous is null, and the previous value is null. Next, what we have to do, its npx value contains XOR of previous, and next. Previous and next. It means it stores previous XOR next. Our previous pointer is null. We need the next pointer from the npx. We are only interested in the next. So we do the XOR with our previous pointer. So after doing the XOR, so let me change the color. After doing the XOR with our previous, we are left with the next. In this case, the next is this 2. So we initialize our next pointer, next pointer to the left out value, So next will point to this. Let me change the color for the current and the previous also. So we saved the current value. We need to initialize previous to current and current to next and current to next. Next, we save this value. So the value is 2. We need to go to next. So its npx, the current node npx stores pointer in this manner. Previous XOR next. Previous XOR next. So previous XOR next. If we do the XOR with the previous itself, means it stores the value of this and this. If we do the XOR of this, means we are removing this, we are left with the next pointer only. So we need to change the next to next. Then we need to change our previous points to current and current point to next. We need to save this value. Value is 1. Then we need to change. We need to find the next value. So next will move to null. Next will move to null. This previous will point to current. Then current will move to null. Now current is null, means we have saved the values, all the values. This is our answer. We just need to return our list. So that's how this algorithm will work. We have two functions. One is insert. We need to insert at the beginning. One is the traversal. So let's code this. We have insert function and getList function. In the insert function, we have to insert a node at the beginning. First, we create a new node. This is our new head with the input data. Next, this new head next will point to the head node. This new head next, this npx will work as next only because the new head previous will be null. After doing that, we have to check, is our head null? Means if we have a linked list or not. If we have a linked list, then the head next is already pointing to somewhere, and head previous will point to our new head. So head dot previous will point to next and previous. It is already pointing to next, and we have to do the XOR. So head npx will now work as the previous and next as well. It is already storing head.npx already storing the next, and new head is the previous node. So after doing the XOR operation, the npx will work as next previous XOR. So we just need to return our new head. Let's talk about getList. We have 3 pointers: current, previous, and next, and answer. While this condition holds, first we need to store our current data. Next, the npx. Npx stores next and previous. Npx means next previous XOR. So current npx means next XOR previous. So if we do the XOR with previous itself, this is very common principle in XOR. We are left with next. This previous will cancel out this previous, then we left out with next. So we will save the next in our next pointer. Previous will point to current, current will move to next. Next, after traversing all the nodes, we just need to return our vector or list. So let's give it a try, and let's talk about time and space complexity. In this function, the time complexity is constant and space complexity is constant. In this function, the time complexity is order of n and space complexity is order of n if we include the vector. If we don't include the vector, because that's the expected return type here, so the space complexity will be constant. So we have met the expected time and space complexity. I hope you have liked this video. Give it a thumbs up, subscribe to this channel, and thank you all for watching.